In today's podcast, we're diving into the concept of reliability in software systems. When we talk about reliability, we're essentially asking, does the system keep working as expected, even when things go wrong? Users want software that performs its intended function, handles errors gracefully, maintains good performance under expected load, and prevents unauthorized access. In other words, a reliable system doesn't just work when conditions are perfect, it works when things break down too. Faults, the things that go wrong, are inevitable in any system. A fault might be a component that doesn't behave as expected, like a hardware issue, or it could be a software bug triggered by an unusual set of circumstances. A reliable system is one that anticipates and tolerates faults rather than failing altogether. This is known as fault tolerance. Now, it's not feasible to make a system immune to all possible faults. Imagine trying to protect servers from a black hole swallowing Earth. But we can focus on the most likely faults and prepare for them. To break it down, there are a few key types of faults we have to deal with. First are hardware faults, which happen when physical components like hard drives fail. For example, with 10,000 disks in a data center, we might expect one to fail every day. That's why we use techniques like redundancy, backups, RAID configurations, and spare power supplies, so that when one part fails, another can take over. However, as systems have grown and cloud computing has become common, we now deal with more machines, which means more faults. Today, it's essential to build systems that can tolerate the failure of entire servers. Software fault tolerance techniques help with this, enabling things like rolling updates without taking systems offline. Then there's software faults, bugs or glitches in the code. These are often more difficult to predict and can cause bigger problems because they might affect multiple systems at once. For example, in 2012, a leap-second bug caused many systems running Linux to hang simultaneously. The problem with software bugs is they often lie dormant until triggered by a specific set of circumstances. That's why things like thorough testing, process isolation, and monitoring are so important. By understanding how the system behaves in production, we can catch these issues before they lead to widespread failures. Human errors are another big cause of unreliability. In fact, many outages are due to configuration mistakes or operational errors. Since humans will inevitably make mistakes, the best systems are designed to minimize the impact of those mistakes. This includes giving people safe environments, like sandboxes, to test changes, setting up thorough testing processes, and ensuring quick recovery methods are in place, such as rolling back faulty updates or recomputing data that was processed incorrectly. So, why does reliability matter? It's not just for critical systems like power grids or airplanes. Even everyday applications need to be reliable. Think of a parent storing precious family photos in a photo app. If that database becomes corrupted, the impact on the user is significant. In business, bugs or downtime can lead to financial losses or damage to a company's reputation. Ultimately, while we might choose to compromise on reliability in early prototypes or low-cost services, we should always be aware of the trade-offs. Building reliable systems takes effort, but it's an essential responsibility to both users and the organizations that depend on them. That's it for today. Thanks for tuning in.